Hey everyone, welcome to Metaverse Marvels. In this series, I'm going to show you step by step how to build a complete character customization system inside Unreal Engine. From switching outfits to adding accessories to applying materials dynamically. Everything will be explained in a clean and simple way so that even beginners can follow along. We'll start from the very basics and slowly build up. You'll see how to structure your blueprints, how to use enums for clean organization, and how to create a smooth, professional-looking UI that feels just like what you see in modern games. By the end of this series, you'll know how to use enums to manage categories like dresses, shoes, glasses, tails, ears, and more. Set up widget switching so the UI feels fluid and easy to navigate. Apply materials dynamically and override slots in real time. Work with dynamic material instances to change colors and styles interactively using sliders. Equip and replace items using enums, so you don't need to hard code IDs. And finally, bring it all together into a modular customization system you can expand for your own projects. I'll break everything down into easy steps without skipping the details. Each part of the system, from the blueprint logic to the UI to the material functions, will be explained clearly so you actually understand not just what to do, but why it works. So whether you're completely new to Unreal or you're already comfortable but want to organize your workflow like a pro, this series will give you the tools and techniques to build your own system from scratch. And that's not all. We'll also look at ways to keep the system flexible. That means you'll be able to add new outfits, accessories, or categories later on without rewriting everything. This is exactly how professional studios approach customization systems. So, if you're interested in Unreal Engine tutorials and you want to build game-ready systems that you can actually use in your own projects, make sure to subscribe and turn on the bell so you don't miss any part of this series. All right, let's jump in and get started with building our character customization system. All right, welcome back to Metaverse Marvels. In this first video of our character customization series, we're going to start right at the beginning by importing our VRoid character into Unreal Engine. Now, for those of you who are new to VRoid, it's a great free tool for creating anime-style characters very quickly. You can customize hair, face, clothes, and accessories without touching 3D modeling software.
Now, here's an important tip for this series. When you set up your hair, eyes, ears, and tail colors inside VRoid, make sure they are all pure white by default. Why? Because later in this series, we'll build a color customization system using sliders for hue, saturation, and brightness. If your base color is white, Unreal can shift it into any color dynamically without weird artifacts. This gives your players full control over character appearance, like choosing hair color or eye color on the fly. And the best part? It exports your character as a ready-to-use 3D model that you can bring into Unreal Engine.
Hmm. Right now, I'm exporting the default VRoid textures for clothing because I don't have my own custom ones ready. And that's totally fine. VRoid already gives you a good set of base templates to work with. Here's something you need to know. By default, VRoid gives you 5 texture layers for clothing. That sounds limiting at first, but don't worry. Those 5 layers aren't shared across everything. You'll actually have 5 texture templates for each category. 5 for tops, 5 for bottoms, 5 for shoes, 5 for accessories, and so on. So it's more flexible than it might seem at first glance. That means you can design multiple looks inside VRoid itself without running out of slots immediately. For example, you can have 5 different shirts saved as textures, 5 different pants or skirts, and 5 different shoes. Then you can swap them in and out as needed. But let's say you want even more freedom. Maybe you want a custom jacket, a unique hat, or a pair of sneakers that VRoid doesn't give you. That's where Blender, Maya, or Substance Painter come in. You can model your own outfits, texture them, and then attach them to your VRoid character before exporting. There's one important rule, though. Make sure your custom outfits have their own materials. And make sure they fit the VRoid rig without breaking the skeleton. If your mesh isn't skinned correctly, animations won't work. And your character's customization will break inside Unreal. So when you build in Blender or Maya, keep the VRoid skeleton intact and just add your clothes on top of it. That way, everything will behave nicely when we start swapping outfits. For this tutorial, I'm keeping things simple. I'm not creating custom clothes in Blender or Maya. Instead, I'm using the default textures that VRoid provides. That way, even if you're a beginner, you can follow along step by step. But I want you to know upfront. The system we're going to build works equally well with VRoid defaults or with your own custom meshes.
Here's one more thing you really need to pay attention to. Inside VRoid, when you're setting up your default clothing textures, make sure the eye icon next to the layer is turned off. If it's on, Unreal Engine won't display the clothes properly once you import the character. So always double check that this little eye toggle is off before exporting. That way, all the clothes, shoes, and accessories will be visible and work correctly in Unreal. All right, let's move into Unreal. First,
I'll export my VRoid character as a VRM file. VRM is VRoid's native format. Unreal doesn't support VRM out of the box, which is why we use a plugin. Now, I'm not covering the VRM plugin setup in this video because I already made a separate tutorial on my channel that explains how to enable and use the plugin step by step. To keep this episode focused, I'll put that link in the description below. So if you haven't enabled VRM support yet, make sure you watch that first. Once the plugin is enabled, just drag and drop your VRM file into Unreal. Unreal will handle the conversion, and your character will appear in the content browser. At this point, you'll see your character mesh along with all the materials. In my case, I'm sticking with the default shirt, shorts, and shoes. But if you wanted to, you could already have replaced those with custom outfits from Blender or Maya, as long as they were properly rigged and had their own material slots. When you look at the materials, you'll notice that VRoid organizes them into just a few slots: hair, face, body, clothes, and shoes. Those are the 5 base categories I mentioned earlier. Later, we're going to use blueprint logic to dynamically override these slots. So when a player selects a new shirt or pair of shoes, Unreal will just swap out the material on that slot in real time. And here's the great part. Even though VRoid gives you only 5 slots per category, our blueprint system will let you treat those as templates. For example, you might have 5 shirts set up as textures inside VRoid, but in Unreal, you can expand that further by assigning completely new materials or meshes as part of your customization menu. So you're not stuck. You're just starting with a structured foundation. So to recap this step, VRoid gives you 5 templates for each category like tops, bottoms, shoes, and accessories. You can expand beyond that by creating outfits in Blender, Maya, or Substance Painter, as long as you give them proper materials and keep the VRoid rig intact. Make sure your hair, eyes, ears, and tail colors are white so we can shift them dynamically with sliders later. And if you haven't set up the VRM plugin yet, check the link in the description for my tutorial on that. All right, that's all we needed for this first video. Welcome back! Today we'll swap the default character with our VRoid model, create a base material to hide clothing slots, and build the customization UI with categories, dresses, tops, shoes, and color sliders. We'll also set up an enum to switch categories cleanly through the widget switcher, just like a professional character creator. Let's jump in. Open the BP third-person character blueprint. In the Components panel, replace the skeletal mesh with the VRoid character we created in Part 1. In this example, I'll assign SK_Lily as the skeletal mesh asset. Next, let's create a material to hide clothing slot. In the content browser, right-click, Material, name it base_matte. Open it, promote the base color to a parameter, and make sure to set the blend mode to translucent. This allows the material to turn meshes fully invisible. Compile and save. Now, back inside the BP third-person character, we'll apply this material. Select all clothing-related slots: shirts, pants, dresses, tops, bottoms, shoes, accessories, ears. Basically every slot you want hidden. Assign base matte to those slots. Leave only the primary visible outfit and shoes assigned to their original materials. This ensures only one set of clothes shows while the rest remain invisible. Press play, and you should now see the character working correctly with only the chosen clothes visible. Next, let's set up the customization interface. In the content browser, add a widget blueprint and name it WP character_C for character customization. Create a new folder named WP. Inside it, open the widget. Drag a canvas panel into the viewport. Add a vertical box and set its anchor to the entire left side. Offsets should be set to 0 for X and Y. Now add a button, wrap it in a border, and place an image inside the button. Assign a dress icon to this image. For the button states, hover and press, set it to Draw as Image. Also add a text block for labeling. Font size 5, italic style with 0 padding. Give the border a background image, then set the border size to fill. Rename the button Dress B. _B. Step 5. Duplicate UI element. Duplicate this structure for other categories. Tops, bottoms, shoes, glasses, arm accessories, head accessories, like cat ears, rabbit ears. Tail color changer. We need to add 2 spacers inside the vertical box, one at the top and one at the bottom, and set their Y size value to 150. Finally, adjust alignment. Select all the text blocks, set vertical alignment to bottom. Label each button clearly. Dress, top, bottom, shoes, glasses, accessories, etc. Compile and save. Add a background image. Let's start with the UI background. Open your widget blueprint. Add an image and set its Z order to -1 so it stays behind all other UI elements. Set its position X and Y to 0 and also set its offset values to 0. Choose a background texture. I'm using a purple indigo gradient, but you can use any image you like. Adjust the size until it fits your screen. This will act as the base layer of our UI. Step 2. Add a category switcher. Next, we'll create a system to switch between different categories. Add a widget switcher to the canvas. Anchor it to the left center of the screen. Rename it Category Switcher. Inside the switcher, add a uniform grid panel. Rename this grid Dress_Grid. This grid will hold our buttons for the dress category. Step 3. Create the first button. Inside the dress ground -dress, add a button. Wrap it inside a border, and inside the border, add an image. For the border, assign a decorative texture. For the button, assign a dress icon. Set the size to 100, or adjust to whatever looks best for your design. Set Draw As to Image and Padding to 0. Rename this button dress_B1. This will be our first dress option. Step 4. Duplicate for more categories. Now duplicate the entire border plus button plus image setup for additional dresses within the same grid. Once the dress grid is ready, duplicate the entire grid itself to create other categories, such as tops, bottoms, shoes, glasses, arm accessories, head accessories like ears or hats, tail. Each grid will go inside the category switcher and will toggle between them later. And hey, let me share something with you guys real quick. Whenever I'm working on projects like this, I always keep a little notebook next to me. Why? Because when ideas come, they come fast. Sometimes while I'm eating or even late at night. Writing them down means I never lose them. That's honestly how I've been able to build systems like this one, step by step, even when it felt overwhelming. So while you're duplicating grids here, remember, the small, consistent steps you take are what build something big. That's true in Unreal Engine, and honestly, it's true in life too. What is a uniform grid panel? A uniform grid panel is a layout container in Unreal Engine's UMG UI system that organizes widgets like buttons or images into rows and columns. The key word here is uniform. Every cell inside the grid is the same size, so everything lines up perfectly without you manually adjusting each element. Think of it like an Excel sheet for your UI. Each cell is evenly sized. You place a button in one cell, an image in another, and they all line up neatly. Why are we using it here? We're using a uniform grid because it keeps all of our customization options, like dress buttons, shoe buttons, or hat buttons, aligned and evenly spaced. If we just dropped buttons randomly on a canvas, they'd look messy, and resizing the screen would break the layout. With a uniform grid, all the buttons are automatically the same size. They stay aligned row by row and column by column. It makes it easy to add or remove items later without redesigning the whole menu. A lifelong analogy. It's like setting up a shelf with equal compartments. You don't want one shelf taller than the other or books falling out because one section is too small. A grid makes sure everything has its place. Clean, balanced, and professional. And that's exactly why game UIs use grids. They make the player's experience feel smooth and intentional instead of clunky. Now, earlier we added a widget switcher and named it category switcher. Let me explain what that actually is and why we're using it. What is a widget switcher? A widget switcher is a special container in Unreal Engine that can hold multiple widgets, like different menus or grids, but it only shows one of them at a time. You can think of it like a deck of cards. The switcher holds the whole deck, but you only see the top card. Behind the scenes, all the widgets are still there, waiting, but only one is active and visible. Why are we using it here? We're using a widget switcher because our character customization menu has many categories: dress, tops, bottoms, shoes, accessories, etc. Without a switcher, all the grids would appear at once, cluttering the screen. With a switcher, only one grid category is visible at a time. Switching between categories is just like flipping to the right page instantly. It keeps the UI clean, organized, and user-friendly. Real-life examples. TV remote. Think of a widget switcher like your TV remote. The TV holds hundreds of channels, but you only watch one at a time. The others are still there, waiting, but you choose which one is active. Tabs in a browser. You might have 10 tabs open, but you're only looking at one tab right now. The switcher is basically your tab bar for UI elements. Closet with sliding doors. Imagine a closet with different sections: shirts, pants, shoes. The closet has them all, but the sliding door only reveals one section at a time. That's exactly how a widget switcher works. In our system here, each grid, dress grid, tops grid, bottoms grid, etc., lives inside the widget switcher. When the player clicks tops, the switcher hides all other grids and only shows the tops grid. It's simple, but it makes the UI feel professional and easy to use. So, while I'm duplicating and renaming these grids, let me be real with you. This is what actual game development looks like. It's not always fireworks, particle effects, or fancy cinematics. Most of the time, it's these slow, steady, almost boring steps. Duplicate, rename, organize. That quietly build the whole backbone of your system. And you know what? Life works the same way. You don't suddenly wake up one morning knowing everything. You learn a little, you repeat it, you make small improvements, and then one day you realize those basics turned into real power. That's exactly what we're doing here, brick by brick, step by step. It doesn't feel glamorous right now, but trust me, this is the part that makes the whole thing stand strong later. Step 5. Add the color changer. For categories that need color adjustments, like ears, tail, hair, or eye color, we'll use a slider. Duplicate one of the existing grids and delete the buttons inside. Add a slider instead. Set the slider's horizontal and vertical alignment to fill so it takes up the available space. Rename it, for example, ears_slider. Repeat this process for hair slider and tail slider. Finally, add a text block above each slider to label them, such as ears, hair, or tail. Set alignment to center and adjust the font size for readability. Create the activation actor. Now, how do we actually bring this UI up in the game? We need a trigger. In the content browser, right-click Blueprint Class Actor. Name it BP_C. Add a box collision. Uncheck Hidden in Game. You guys know. If this is checked, the box disappears during play. With it unchecked, we can see the trigger box while testing. This box will act as our zone. When the player walks into it, the customization menu will pop up. Add a custom camera. Inside the third-person character blueprint, add a new camera component. Place it in front of the character so it captures a good view for customization. Adjust until you're happy with the framing. We add a new camera because the default follow camera is too far away. A closer, fixed view makes customization much easier. Step 9. Overlap event logic. Back in BPC, select the box collision. Add onComponent begin overlap. Cast to third-person character. Get the new FOV_camera. Add set active equals true so it switches to this camera. Duplicate the set active node. Get the follow camera and set it to false. This is how we make the game automatically switch cameras when the player steps into the customization zone. Step 10. Disable input and show widget. Now, we don't want the character moving around while customizing. From the player controller, call Disable Input. Create the customization widget and add to viewport. From the player controller, call Set Show Mouse Cursor equals True. Create an enum for categories. Now, let's set up category switching with an enum. In the content browser, create a new enumeration. Name it eShow Category. Add entries for every category. Dress, tops, bottoms, shoes, glasses, arm accessories, head accessories, tail, color changer. Honestly, enums are like writing a grocery list. If you don't write it down, you end up wandering the store, forgetting half of what you needed. But with a list, you know exactly where you're going. Same with enums. Instead of chaos, everything is labeled and structured. That's why we use them here. It's not just clean code, it's peace of mind. Inside the widget, create a function called show category. Add an input of type eShowCategory. From the category switcher, call set active widget index based on the enum input. You guys know enums are way cleaner than hard-coding indexes. It keeps the system scalable, so if you add more categories later, you just add them in the enum instead of rewriting everything. Step 12, hook up the buttons. Finally, hook the buttons up. Dress button on-clicked, show category dress. Tops button on-clicked, show category tops. Repeat for bottoms, shoes, glasses, etc. Now, when you click each category button, the correct grid shows up. And that's it. We built a clean background, created grids and sliders for categories, added spacers for a polished look, built a trigger actor with a box collision, set up a new camera, switched cameras on overlap, disabled movement, showed the widget and cursor, and finished with an enum-driven category switcher. Now when you walk into the trigger box, the camera switches, the customization menu opens, and you can navigate between dresses, tops, shoes, and more. You guys know, little by little, this is starting to feel like a professional character customization system you'd see in real games. In the next tutorial, we'll make the buttons and sliders actually change the character's outfit, accessories, and colors in real time. So compile, save, test it, and enjoy seeing your customization menu come to life. Hey guys, thanks so much for watching. If you found this helpful, please don't forget to like and subscribe, and let me keep making tutorials like this for you. And I'd love to hear from you. If you have any thoughts, ideas, or even challenges you're facing in Unreal Engine, drop them in the comments below. I always check them, and your feedback helps me know what to cover next. See you in the next episode. Hey everyone, welcome back to the character customization series in Unreal Engine 5.6. Today we're creating the variables and maps that power our outfit system, adding a clear function so clothes don't stack, and wiring our UI buttons so players can swap outfits smoothly in real time. By the end, you'll have a clean, professional base for character customization. All right, so now we're inside our third-person character blueprint, and this is where I'm going to start creating some variables. Why here? Well, the third-person character is basically the brain of our player character. It's where all the logic for movement, cameras, and interactions lives. So it makes perfect sense to also store our customization data here. Things like which clothes are showing, which materials we're applying, and which slots we need to override. Now, let's pause for a second and talk about what a variable actually is. Think of a variable like a little storage box with a label on it. You put information inside the box, and later you can pull it out whenever you need it. In game development, variables are everywhere. Health, score, ammo, level progress, they're all stored in variables. For our system, variables will keep track of which slots belong to which clothing categories and what materials we can swap in. But here's the catch. One slot is rarely enough. Your character doesn't just have one mesh for clothes. It might have multiple dresses, multiple tops, several shoes, and more. That's where arrays come in. An array is like a shopping list. Instead of holding just one item, it can hold many of the same type. So here we're going to create 9 variables for our customization system. The first one is a material instance variable, and this one is special. It's of type name and map. Why a map? Because we want to link a slot name to the material that should go on it. Think of it like a dictionary. The slot is the word, and the material is the meaning. That way, Unreal always knows which material belongs to which slot. The other variables, like dress slots to override, top slots to override, bottom slots to override, shoe slots to override, armac slots to override, tail slots to override, ear slots to override, and glasses slots to override. These are all arrays. Why arrays instead of maps? Because each category can have multiple slots inside the skeletal mesh. For example, a character might have 3 different shoe meshes or 2 different tops. Instead of making a separate variable for each one, we just keep them all together in a list. That's the array. Then, whenever the player clicks on an option in the UI, we can loop through that array and apply changes to every slot in that category. So, in short, map variable, material instances, equals link slot names to materials, like a dictionary. Array variables, slots to override, equals store multiple slots for each clothing category, like a shopping list. This setup makes our system both organized and scalable. Easy to manage now, and easy to expand later when we add more outfits or accessories. All right, let's start with our very first variable, the material instance map. Go ahead and add a map element to it. Now, open up the sk_lily skeleton and copy the material slot ID. You could rename the slot IDs if you want to keep things cleaner, but in my case, I'll just use them as they are. The only small change I make is deleting the word instance from the names. That way, they won't accidentally override each other and things stay a bit more organized. And one important note here, guys, make sure every slot has a unique ID. If 2 slots share the same ID, Unreal might get confused and override the wrong one, so always double-check your naming. Once you've got the slot ID copied, paste it into the variable we just created, and that links it directly to the material instance we want to assign. So now that we've given our slot ID, we also need to assign the material instance that goes with it. Basically, for every slot ID we add into this map, we pair it with the exact material we want applied there. Why do we do this? Because the slot ID tells Unreal where the material should go, and the material instance tells it what should actually appear. If we only gave the ID without the material, nothing would change visually. And if we only gave the material without the ID, Unreal wouldn't know which slot to apply it to. By pairing them together in this map variable, we're essentially building a little instruction list. Slot 01, red dress material. Slot 02, blue jeans material. Slot 03, leather shoes material. And what happens when we do this? Later, when the player clicks a button in the customization UI, Unreal can just look up that slot ID in the map, find the material we assigned to it, and apply it instantly. No confusion, no guesswork, everything is organized and automatic. This is what makes our system flexible and scalable. If you want to add 10 more outfits later, you don't need to rewrite code. You just drop new entries into this map, and Unreal already knows how to handle them. All right, we're done with the material instance map, so let's move to dress slots to override. What is it? Dress slots to override is an array of slot IDs for every dress mesh/material slot on our character. In simple words, it's a list of all the dress-related slots we might want to change at runtime. Why do we create this variable? Because a character can have multiple dress slots. Dress 01, dress 02, trim, belt, etc. If we only stored a single slot, we'd miss the rest. With an array, we can batch update all dress parts at once, show, hide, swap, loop through every slot cleanly, no copy-paste nodes for each slot. Scale later, just add new dress slots to the list, no logic rewrite. Why an array and not a map? Array equals a set of targets, which slots to act on. Map equals a lookup table, slot arrow specific material to apply. We already used a map for this slot gets that material instance. We use arrays for these are all the dress slots we need to touch together. Both work together. The array tells us where to act. The map tells us what to apply. What to add here? Open sk_lily, or your character mesh. Look at the materials list and collect every slot ID related to dresses. For example, dress_01, dress_02, dress_trim, etc. Add each of those slot IDs into dress slots to override, as name or string depending on your setup. Stay consistent with how you keyed your map. Bonus best practices. Keep slot IDs unique and consistently named. If you add a new dress mesh later, just append its slot ID to this array. No logic changes needed. If some dress pieces share a material, they can still live as separate slots. The loop handles them all. Now let's quickly mirror this pattern for the rest of the categories. Top slots to override, all top-related slot IDs. Bottom slots to override. Arm axe slots to override. Shoe slots to override. Tail slots to override. Ear slots to override. Glasses slots to override. Each one is an array for batch operations on that category. This is what makes your customization system modular, clean, and production ready. All right, let's create a new function here and call it material_from_map. Why do we need this? Because instead of writing the same find material and set it on slots logic over and over, we'll keep it all in one clean place. Anytime the player picks an outfit, we'll just call this function and it will handle everything. Look up the right material and apply it to the right slots automatically. Adding the inputs. Now let's set up our inputs. Item ID. Set the type to name. This is basically the unique identifier for the item or outfit we want to apply. It's like the key you'll use to look up the material. Material map. Set the type to map, where the key is a name and the value is a material instance. This map is our dictionary. It links an ID to the exact material instance we want to apply. So, for example, dress_red could point to m_dress_red_inst. Slots to override. Set the type to name array. This is a list of all the material slots on the character that we want to change when this item is selected. Think of it like saying, these are the slots that belong to dresses. Update all of them at once. Building the logic. Now let's build the function itself. Drag in the material map input and add a find node. Plug the item ID into the find name pin. This will search the map and try to get the material instance that matches the given ID. Add a branch node. The branch checks if the material was actually found in the map. If true, we have a valid material to use. If false, the ID wasn't found, so we'll use our base mat to hide or clear that slot instead. Drag out the slots to override input and add a for each loop node. This loop will go through every slot name we passed in, so we can update all those slots one by one without copy-pasting nodes. From the loop body, if the branch says true, material found, call setMaterial by name. Target, the mesh, your character's skeletal mesh. Material slot name, the current array element from the loop. Material, the material we got from the find node. If the branch says false, no material found, call setMaterial by name again, but use base_mat.
This way, if we don't have a custom material for that item, we just make the slot invisible or clear. Why this is important. This single function does all the heavy lifting. The map lets us quickly look up the right material using just an ID. The array means we can handle as many slots as we need in one go. The branch makes it safe. If something's missing, we fall back to our base mat instead of breaking the system. See this not equal check here? This one is really important for keeping our outfit swaps clean. Here's the problem it solves. Imagine the player is already wearing the red dress. Now they click on the pink dress. If we just blindly add the pink dress material on top without first clearing the red one, the character ends up looking like they're wearing both dresses at the same time, layered and messy. That's not what we want. So what we do is simple. First, we check. Is the current slot's item ID not equal to the new item ID the player picked? If it's not equal, meaning the new item is different, we first set the material to /base_mat to clear the old dress. Then we apply the new material for the new item. This way, when the player switches from red dress to pink dress, the red is fully removed first and only the pink is visible. No stacking, no weird overlap. The character always looks clean and only shows the chosen outfit. Open WP_character_C. In the graph, use the event construct node. Right after setShowMouseCursor equals true, add getPlayerCharacter not controller, cast to BP, third person character, or your character BP. Promote the cast result to a variable and name it BP_character. This avoids having to do getPlayerCharacter plus cast every time a button is clicked. Clean and efficient. Now let's wire up the dress button. We're inside our widget graph, WP_character_C. On the dress button, I've added the onClicked event. From here, we use the BP_character variable. This is the reference we created earlier when we casted to our BP_third person character. Instead of calling getPlayerCharacter to cast every single time a button is clicked, we keep this reference once and reuse it. Next, we drag out from BP character and pull in the variables we already set up. Material map, the map that links each item ID to its correct material instance. Dress slots to override, the array of slot names where the dress material should be applied. Then recall the function material_from_map and connect everything. Target arrow BP_character item ID arrow the ID of the dress we want to equip. For now, you can just type it. For example, the material slot name, such as dress_pink_01. Material map 2, the material map variable on the character. Slots to override 2, the dress slots array. What happens when you click the button? The item ID you passed is sent to our material_from_map function. The function looks up that ID in the material map and finds the correct material instance. It loops through every slot in dress slots to override and applies the new material. Thanks to the not equal check we added earlier, it first clears out any previous dress. So if the player was wearing a red dress and clicks a pink one, the red dress is removed before the pink is applied. No more weird overlapping outfits. Now let's add the rest of the dresses. Repeat the exact same setup for every other dress option you want to include. Select the Next Dress button in your UI. Go to its onClicked event. From the BP_character variable, plug in the same material map, your dress material map. Dress slots to override, arrow right, your dress slots array.
call material from map again. Set the item ID to match that dress, e.g. dress underscore blue underscore 01, dress underscore green underscore 02, etc. Now let's test it out. Hit play and try clicking on the dress buttons in the UI. You'll see. Every time we click a different dress, the outfit actually changes in real time. The previous dress gets cleared first and only the new one appears. Pretty cool, right? Let's wire the tops button, same as we did for dress. Copy-paste the dress logic. In WP underscore character underscore C, select the dress button's on-clicked graph. Copy it and paste under the top buttons on clicked. Update just two things. Item ID change to your top's ID, for example, top underscore black underscore 01. Slots to override switch from dress slots to override to top slots to override. Test hit play. Click a dress, then click a top. You'll notice the top appears over the dress. They're stacking. That's expected right now because we haven't cleared the dress slots first. Let's fix the overlap with a clear function. Create clear in BP third-person character. Open BP third-person character, add a new function and name it clear or clear slots. Add an input called array of type name and array. This will hold the slot IDs you want to clear. Inside the function, use a for each loop on the array. For each element, use set material by name. Set the target to mesh, the material slot name to the array element, and the material to clear material. Set clear material's default value to base mat. This way, every slot you pass in will be reset to the base material so nothing stacks or overlaps. Use clear before applying tops in WP underscore character underscore C. Go to the top button's on-clicked event. From BP character, call clear and pass dress slots to override to remove any dress first. Test your setup. Play the game, pick a dress, and then click a top. The dress clears first, then the top appears with no overlap. If you click the same top again, the not equal check prevents it from reapplying. And if you switch to another top, it swaps cleanly. Apply the same logic to all categories. For dress on clicked, clear top slots to override first, then call material underscore from map for the dress. For top on clicked, clear dress slots to override first, then call material underscore from map for the top. For bottoms, clear any conflicting dress. The simple rule is always clear the conflicting categories slots with clear first. Then call material underscore from map to equip the new item. Do this for each category. Copy the working on-clicked logic from any button. Change item ID to the correct ID for that category. Example, bottom black 01, shoes white 02, glasses round 01. Change slots to override to that category's array. Example, bottom slots to override, shoes slots to override, glasses slots to override. Remember the clear step to prevent overlap. Bottoms button. Call clear on dress slots to override first, then call material underscore from map for bottoms. Dress button. Call clear on top slots to override first, then apply the dress. Tops button. Call clear on dress slots to override first, then apply the top. Quick test routine. Play, click through each category, confirm only the chosen item shows, no stacking. Clean swaps when changing items in the same category. Note for you guys. For now, we're keeping it simple by typing the item ID manually as a name when we connect the button. That's the fastest way to show the system working. But don't worry. In the next step, we'll upgrade this by using an enum instead of manually typing names. That way, the whole setup becomes much more scalable and easier to manage when you add lots of outfits or want to refactor later. Enum keep your IDs consistent and save you from typos. So we'll switch to that soon. Quick personal reason I love enums. They turn chaos into calm. Years ago, I had a dropdown of 20 string IDs. One typo and nothing worked. Enums said, nope, pick one from the list, and my bug rate dropped instantly. Next episode, we'll switch to enums, so your system scales without becoming spaghetti. I'd love to hear your tiny win in the comments. Did you create your own category, maybe necklace or socks, and hook it up to swap like we did today? If you did, I'm cheering for you. You're doing amazing. Please share it so I can celebrate with you. And if not yet, no worries. Give it a try. I know you can do this. I'm showing you every single category, not skipping any steps. Why? Because I know when you actually see 3 or 4 full examples, it clicks so much better. If I only showed one and said, just repeat it, you'd probably still have questions. So we're going through each one together to make sure you really understand how to build the whole system. Since we're doing the same setup for all categories, don't zone out. Try this with me. Pause, wire one button, test it, then come back. Tiny wins count. And here's a quick tip. If something doesn't show, double check the slot name. Make sure it's in the array and confirm the item ID matches the map key. Also, tell me your next category idea. Necklace, cape, socks, and I might feature it next episode. You've got this. While we're wiring up all these categories the same way, dress, top, bottoms, shoes, let me tell you a little story. When I first built a customization system like this, I thought I was being super smart and skipped the boring repeat steps. I said, I'll just wing it later. Spoiler, future me was not impressed. My character ended up wearing a dress, a top, and somehow 3 pairs of shoes at once. Looked like a fashion disaster. That's why I'm walking you through every single category now. Repetition might feel slow, but it's what makes your system rock solid. Every slot you add and every clear you wire in is one less weird double shirt bug you'll have to hunt at midnight later. So trust me, this is the good kind of boring. Okay, now let's test and play. Looks like everything's working. Pretty awesome. Next video, we'll add the color sliders to bring the customization to life. If this helped, please like the video and subscribe so you don't miss the next part. And drop your questions or tiny wins in the comments. See you in the next one. Bye, guys. Take care. Hey, everyone. Today, we're turning our character customization into the real deal. Wiring every category, preventing outfit stacking with a clean, clear step, adding a back button for smooth exit, and dropping in color sliders. Hair, ears, tail, eyes. Quick, satisfying upgrades you'll feel immediately. Tiny clicks, big glow up. All right, let's start. Before we dive in, quick confession. Game dev isn't always epic boss fights and explosions. Half the time, it's just me, my coffee, and 100 tiny clicks naming slots and maps until it all works. And honestly, that's where the real magic happens. All right, let's get started. All right, let's set up the pieces for live color control. First, I'm creating an enum called eOutfitPart. I'm adding 4 entries: hair, cat ears, tail, and rabbit ears. Using an enum keeps everything tidy and prevents string typing mistakes later. Now, in my third-person character, I'm adding 3 variables, all keyed by that enum. Part slot name map is a map from eOutfitPart to name. This stores the exact material slot name on the mesh for each part. For example, hair points to the mesh's hair slot name. Part base mat map is a map from eOutfitPart to material or material instance. This is the base material I want to start from for that part. Part MID map is a map from eOutfitPart to material instance dynamic. This will cache the dynamic material instance we create so we don't make duplicates every time. With that setup done, I'm creating a function called getOkMid. It takes a single input called part of type eOutfitPart, and it returns one value called MID of type material instance dynamic. Here's what the function does step by step. I start by trying to reuse work. I look up the incoming part in part MID map using a find node. If a MID is already stored for this part, the branch goes true, and I immediately return that cached MID. That's the fast path, and it keeps performance solid. If nothing is cached, we need to create a new MID. First, I need to know which slot on the mesh I should use.
I ask part slot name map for the slot name that belongs to this part. With that slot name, I call getMaterialIndex on the mesh so I get the correct element index for createDynamicMaterialInstance. Next, I decide which source material to use. I try part-base-mat-map with the same part. If it returns a valid material, I'll use that. If it doesn't, I call getMaterialByName on the mesh using the same slot name. That gives me whatever material is currently assigned to that slot on the mesh. If for some reason that's still not valid, I can safely fall back to base_mat so the function never fails. Once I have a valid source material and a correct element index, I call createDynamicMaterialInstance. Target is the mesh, element index is the index I just looked up, and the source material is the one I chose. The result is a fresh MID tied to the exact slot for this outfit part. Right after creating it, I store that MID back into part MID map under the same part key. This means next time we ask for this part, the function will find it immediately and just return the cached instance. Finally, I pass the MID out through the return pin. That's the whole function. Now, let me explain why we built it. When we add color sliders in the next video, we need a stable, per-part dynamic material that we can tweak in real time. This function guarantees we always get the correct MID for hair, cat ears, tail, or rabbit ears. It finds the right slot, picks a good source material, creates the MID once, caches it, and reuses it. The enum removes typos. The maps keep everything organized and scalable. And the fallback path makes the system robust even if a setup is incomplete. In short, whenever a slider moves, we call getMIDPart, grab the MID instantly, and set parameters like color or roughness without any extra wiring. Now we've created a new function in our widget called ColorCF. Think of this as the color change controller for our character. Whenever the player moves a color slider in the UI, ColorCF runs. Its job is to go part by part, hair, cat ears, tails, rabbit ears, etc., and update their material colors in real time so the player instantly sees the change. Inside the function, we use a for each loop to walk through our part array. Each item in this array is one of the outfit parts from our enum eOutfit part, like hair, cat ears, or rabbit ears. It's like saying, let's visit each part of the character one by one and repaint it with the color the player just picked. For every part, we call our getOrCreateMID function. This either fetches an existing dynamic material instance, if we've already created one for that part, or makes a new one if it doesn't exist yet. Think of it like paint cans in real life. If you've already opened a can for this wall, just use it again. If not, grab a new one. The color slider gives us a simple value between 0 and 1, but that's not enough for a full color spectrum. So we use mapRangeClamped to convert the 0 to 1 value into 0 to 359, a full circle around the color wheel. Then HSV to RGB turns that wheel position into a color Unreal can actually use. It's like turning a rainbow dial and getting the exact color mix ready for painting. Finally, we call setVectorParameterValue twice, once for midtone color, the base color, and once for midtone shade color, the shadow tone. This instantly updates the material color of each part, so as the slider moves, the hair, ears, or whatever part is selected changes color live. Perfect. Now let's set up those maps inside VP third-person character. In the part slot name map, we've added 4 keys from our enum eOutfit part: cat ear, tails, rabbit ear, and hair. Each key is assigned to the correct slot name on the mesh. For example, cat ear is linked to accessory_cat_ear_01_cloth. Tails to accessory_foxtail_1_cloth. Rabbit ear to accessory_rabbit_ear_01_cloth. And hair to N0hair00hair.
Think of this map as a directory that tells Unreal which slot name belongs to which part of the body. When we say hair, it knows exactly which slot on the mesh to target. Then in the part-based mat map, we mapped those same parts to their default materials. Cat ear is linked to MI accessory cat ear 01C. Tails to MI accessory foxtail 01. Rabbit ear to MI accessory rabbit ear 01. And hair to MI underscore N0 underscore HAIR underscore 00 underscore HAIR. This map acts like our paint supply. Each slot has its own base material we can clone into a dynamic material instance when we want to change colors. This step matters because without these maps, Unreal wouldn't know which slot is hair or which material to start with. Now, when our getterChainMid function runs, it can look up the correct slot and base material, create a dynamic instance, and apply color changes in real time. We've selected the hair color slider inside our widget and used its onValueChanged event. This event fires every single time the player moves the slider, even a tiny bit. Think of it like a dimmer switch in your room. Every time you slide it, the light updates in real time. The slider sends out a value, a number between 0 and 1. That number represents where the player's slider handle is, all the way left, 0, to all the way right, 1. We'll turn this number into a color later. Then we make an array with a single element, hair. Why an array if it's just one thing? Because our color shaft function expects a list of parts to update. If tomorrow we want to let this same slider also change the color of, say, cat ears at the same time, we could just add another part into this array. It keeps things scalable. We connect that array with hair and the slider value into the color impoverished function. When the player moves the slider, it tells ColorSSF, hey, go update the hair part using this new value I just picked. Inside ColorCMS, as we explained earlier, the value is converted from 0 to 1 into a full 360-degree hue range, using MapRange clamped and HSV to RGB. Then we grab the dynamic material instance for hair and set its color parameters, mToon color and mToon shade color. Why this is powerful. Instead of pre-making dozens of hair color materials, red hair, blue hair, green hair, we now let the slider drive the color in real time. The player gets instant feedback as they drag the slider, just like picking a paint color and immediately seeing the wall change. Oh man, the color looks super weird right now when we move the slider. Definitely not what we want. Feels like we might have missed a tiny connection somewhere. Let's take a closer look together. Oh, there it is. We forgot to connect the setVectorParameterValue node to the HSV to RGB output. Because of that, the material wasn't getting any color data at all, so it defaulted to black. Such a tiny detail, but it makes a huge difference. This is one of those classic, one unplugged wire and everything looks broken moments in Unreal. Always double-check those node connections when something feels off. Most of the time, it's just one small wire missing. As you guys know, sometimes when we close and reopen the editor, we start getting that classic accessed none trying to read property error. It's Unreal's way of saying, hey, you're trying to use something that doesn't exist right now. Here's how to fix it. Go into your ColorSef function and add an isValid node before the setVectorParameterValue nodes. Take the output of isValid and connect it to the execution pins of those setVectorParameterValue nodes. What this does is simple. It checks, do we actually have a valid material instance before we try to change its color? If it's not valid, Unreal just skips that step instead of throwing an error. Now compile and play. No more accessed none errors. Smooth and safe. All right. Problem solved. Okay, guys. Now we're adding a brand new eyes color slider. First, just duplicate one of the existing sliders in the widget, for example, the hair slider, and rename it to Eyes so we have a fresh control ready. Next, jump over to your enum outfit part and add a new entry called Eyes. This way our system officially knows that Eyes is a customizable part, just like hair, cat ears, tails, and rabbit ears. Now open your BP third-person character in part basemat map. Add a new map element for Eyes and assign the base material your eyes should use. In part slot name map, add Eyes and give it the correct slot name from your mesh, the material slot that controls the eye color. Finally, go back to your widget and select the Eyes slider. On its onValueChanged event, hook it up the same way we did with hair. Make an array with the Eyes enum value. Pass the slider's value into our colorCF function and connect it. Now hit play and test. Move the Eye slider and watch the character's eye color update live. Looks awesome. Now our customization covers eyes too. Clap. All right, time to add a back button so players can exit the customization view like pros. First, drop a back button into the widget and style it however you like. Text, icon, rounded border, little hover glow. Make it cute. Now bind onClicked. Inside onClicked, use the BP_character reference we cached on event construct. We're going to swap cameras back, restore controls, and close the UI in one smooth motion. First, set your FOV camera inactive using setActive. Then set the follow camera active using another setActive. Think of it like walking out of the dressing room and back onto the game floor. FOV camera off, gameplay camera on. Next, give control back to the player. Call enable input using the player controller you cached. And if you showed the mouse earlier, set show mouse cursor to false and switch input mode back to game only. Finally, close the UI by calling remove from parent on this widget. Quick recap you can say while clicking. Back button pressed. Turn off the FOV camera. Turn on the follow camera. Re-enable input. Hide the mouse. And remove the widget. Clean exit. Little fun check before we celebrate. Hit play. Open the customization. Press back. You should snap from the close-up FOV back to gameplay. Movement returns. Mouse disappears. And the UI is gone. If anything feels off, double-check which camera you're toggling and make sure you're enabling input on the same player controller you used earlier. Pro tip. The back button is your graceful exit. Make it feel silky. A tiny fade or sound cue here goes a long way. And yes, I clap a little every time it swaps perfectly. Okay, spot the tail. It's clipping and doesn't look great. Let's fix it fast in the animation blueprint so it moves naturally and stops diving into the clothes. Open the third-person character's anim blueprint. Add a VRM springbone node to the graph and wire it into the output pose. This gives the tail secondary motion with spring physics so it reacts smoothly when the character moves. In the VRM springbone settings, disable Ignore Physics Collision. This prevents the spring sim from doing weird micro-collisions that push the tail through the body or outfit. Compile and save, then hit play. Check the result. The tail should sway naturally, settle nicely after movement, and, most importantly, not sink into skirts or jackets. If it's still too floppy, lower stiffness slightly. If it's too stiff, raise drag a touch. Little tweaks here make a big difference. Looks way better now, right? Next up, we'll tidy the blueprint, swap our item ID strings for a proper enum, and lock the system down so it's reliable and easy to grow. And a quick story before we wrap. The first time I demoed a customization menu, everything looked perfect. Until my cat strolled across the keyboard and swapped the outfit mid-sentence. I thought I broke the whole thing. Turned out the logic was solid. It just needed cleaner inputs. That's why we're polishing now, so even surprise playtesters can't knock it over. If this made you smile or saved you time, drop your tiny win in the comments and tell me what part you want to customize next. See you in the next one. Thanks for watching. If this helped, please like and subscribe. Hi everyone, this is the final video of our character customization series in Unreal Engine 5.6. Today we'll wrap up the whole system, collapsing our nodes into clean functions for tops, bottoms, dresses, and accessories, adding clear comments and hooking everything to UI buttons so it's easy to expand later. By the end, you'll have a professional, organized customization setup ready for any future outfits or colors. Let's finish strong. All right, guys. Welcome back. Today we're going to wrap things up and organize our whole customization system so it's cleaner and way easier to scale. Up to now, we've been typing plain text IDs whenever we wanted to swap an item. That's okay while testing, but it's not the most reliable long term. So now we'll switch to an enum system. This will make everything easier to maintain and add new gear without breaking our logic. First, open BP third-person character and create a new function. Call it enum to item ID. Next, create a new enum called eAccessory ID. Add entries for all the items you want. Things like white boots, cat ear, rabbit ear, foxtail, round glasses, pink bow shoes, navy. All right, friends. Now we're going to add our entries to the enum. This is where we teach Unreal the actual names of every item our character can wear. And I know this step might look a little boring, just typing names one by one, but honestly, I find it kind of special. It's like when you're organizing something meaningful in real life. I remember when I was younger, I loved to keep a little box with all my favorite things. Tiny hair clips, stickers, a favorite bracelet. I'd label each little section so I'd always know where everything belonged. Cat ears go here. Rabbit ears go there. Dresses here. It was my way of making chaos feel beautiful and easy to navigate. That's exactly what we're doing now. We're building a closet for our character. Each name we add is like saying, "Hey, Unreal, this is where the pink bow shoes live. This is where the white boots live." So later, when the player clicks a button or changes a style, Unreal doesn't get confused. It just opens the right drawer and picks the correct thing for them. And honestly, I think this is what makes customization systems feel magical to players. They don't see all this behind-the-scenes labeling we're doing, but because we took the time to set it up, everything feels smooth and effortless when they use it. So while it might feel like we're just typing names right now, what we're really doing is creating a little organized world for our characters' outfits. One where everything has a home and nothing gets lost. Now, back inside the enum to ID view function, add an input of type eAccessory ID and an output of type name. Drop in a select node, connect your enum input to it, and for each entry, give the real material slot name. For example, cat ear accessory underscore cat ear 01 underscore cloth, white boots n, etc. Okay, friends, now we're at one of my favorite little blueprint tricks, the select node. This thing is like a secret control center for our customization system. What we're doing here is teaching Unreal, if the enum says cat ear, use this exact slot name on the mesh. If it says white boots, use that one. If it says pink dress, boom, that's the right slot. Think of it like this. One day I went shopping for clothes. I walked into this cute little store and I didn't know where anything was. I just told the shop lady, "I need something cozy for winter." She didn't ask me for details. She smiled, vanished into the back, and came out with the perfect warm sweater. Then I said, "Actually, I want something fun and fancy for a party." And without missing a beat, she disappeared again and came back with the cutest dress. That's exactly what the select node does for us. We don't have to write 1,000 instructions like, if it's cat ear, then do this. If it's rabbit ear, then do that. If it's pink dress, blah, blah, blah. Instead, the select node is like that magical shop assistant. You give it the category, our enum, and it just knows where the right thing is stored and hands it to you instantly. And this is where it gets fun. Because if you decide to add something new later, like say you just made a pair of epic combat boots or some new cute accessories, you don't have to rewrite a big messy pile of code. You just add a new entry to the enum, drop its slot name here in the select node, and our whole system is instantly aware of it. No chaos, no spaghetti code, just clean and organized. Honestly, I love this step because it's like labeling your closet. You open it, and instead of digging for hours, everything is in its perfect spot. Sweaters here, coats there, dresses there. When we want to swap something on the character, we just say its name and boom, the select node knows exactly where it lives. It's such a tiny thing, but it makes your whole customization system future-proof and so much easier to maintain. Then head over to your WP_character_C widget. Where we used to type the item ID manually, call the enum2id function from our BP character instead. Tip: set the enum2ij function to pure so it stays nice and clean. Next, tidy up your blueprint by collapsing each category into its own function. For example, make a dress function with an input called dressID, type eAccessoryID. Hook it up to enum2GitHub material from map and connect the right slot arrays. Then just duplicate that function for tops, bottoms, shoes, accessories. Swap the enum entry and slot arrays as needed. Finally, hit play and test each category one by one. Everything should now be organized, scalable, and super easy to expand. Adding a new item is as simple as adding an enum entry and updating one map. All right, friends. Now that we've got all these wires and nodes doing their thing, let's take a deep breath and make it neat and easy to use. Right now, everything is a little scattered. We've got our enum to item ID set up, our material maps, and all these connections. It works, but it's not very friendly, is it? Think about it like your kitchen counter after cooking a big meal. You've got plates, spoons, spices, everything all over the place. It worked while you were cooking, but now it's a mess. So let's clean it up. We're going to take these nodes and collapse them into nice, clear functions. For example, we'll make one called dress, one for tops, one for bottoms, and so on. That way, when we want to change something later, we don't have to dig through a jungle of wires. We can just call a clean function that says exactly what it does. I love doing this part. It feels like organizing your clothes after laundry day. You know when you fold each shirt and place it into its drawer, then suddenly your whole room feels peaceful? That's exactly what we're doing for our blueprint right now. One day, I remember reorganizing my work desk. I had cables, pens, notebooks all mixed up. It felt overwhelming. But when I finally took a few minutes to put each thing in a labeled drawer, my brain felt lighter, and working became so much easier. This is the same thing. We're making our blueprint breathe. Plus, by collapsing these nodes into functions, you future-proof your system. Want to add more bottoms later? Just update the bottom function. Want to tweak how dresses are applied? Open the dress function. No need to hunt around and reconnect wires. It's clean, reliable, and way easier to expand later. So let's tidy this up now. I promise, once you collapse these into neat little function boxes, you'll look at your blueprint and feel that same moment you get when you finally clean your desk or closet. It's not just about code, it's about peace of mind. If you're new to Unreal, this might feel abstract at first, but once you get it, you'll feel like you've unlocked a secret power. A function is basically a reusable little machine that you build once and can use anywhere in your blueprint. Imagine you're cooking. Every night you have to chop vegetables, wash them, season them, and throw them in a pan. If you had to explain every single chopping step each time you made dinner, you'd go crazy. Instead, you just say, "I'm going to cook veggies," and your brain runs through the whole process automatically. That's what a function does in Unreal. It packages a set of instructions so you don't repeat yourself. You give it inputs, ingredients, and it gives you an output, your finished dish. Now, inside blueprints, there are two main kinds you'll see: normal functions and pure functions. A normal function is like cooking dinner and then leaving the kitchen a bit messy. It can change things in the world. When you call a normal function, it might update variables, move your character, change the game state, spawn an actor. Basically, it does something. It's like flipping a light switch. You don't just ask what the state of the light is, you're actually changing it. A pure function, though, is different. A pure function is like asking a calculator, "Hey, what's 2 plus 2?" It doesn't change anything. It just looks at the information it already has and gives you an answer. No side effects, no mess. It just returns a value based on what you pass in. Here's a real-world Unreal example. Let's say you have a function called getHealthPercentage. All it does is look at your current health and max health and tell you the percentage. It doesn't change your health, doesn't spawn anything, doesn't mess with the world. It's pure. Unreal can even run pure functions automatically whenever it needs the result, because it knows they're safe. Now compare that to a normal function like DamagePlayer. When you call it, it actually lowers the player's health. That's a side effect. So it's not pure. It's something you have to trigger intentionally. So, big picture. Functions equals reusable steps you can call anywhere so you don't repeat yourself. Normal functions equals can change things in your blueprint or world. Pure functions equals only calculate and return information. Safe, predictable, no side effects. We used a pure function for enum to a frame because it's a simple lookup. Give it an enum, get an item ID back. That keeps our blueprint clean, fast, and safe. If you remember nothing else, remember this. Whenever you just need an answer, no world changes, no spawning, make it pure. Whenever you need to do something, move, change, spawn, set, make it a normal function. Once you get into this habit, your blueprints become cleaner, more organized, and way easier to maintain. Okay, friends, let me share something really helpful and a little personal. When I was younger, I went to a small local festival where everyone was showing their crafts and art. There was this one lady selling handmade journals, and she told me, "If you want someone to enjoy what you've built, make it easy for them to understand. Leave small notes, tell a story, make it friendly." That stuck with me. So here's my pro tip for your blueprint work. Always leave yourself breadcrumbs. Add clear comments, use clean function names, and group logic so that future you, or anyone else opening this project, instantly understands what's happening. Game development can feel like building a parade float. During the festival, it's colorful and fun. But months later, when you have to fix one wheel, you'll be grateful if you labeled where every part connects. So let's be kind to our future selves. Add comments that explain why, not just what. Collapse nodes into neat, reusable functions. Keep your enums and maps organized. This little habit will save hours when you return after a long break, or after a late night of coding and festival fun. Top category. In your widget/character graph, select the whole node chain that equips a top clear enum to iMaterial_from map, any prints/safety checks. Right-click, collapse to function. Name it top. Give it one input, top ID. Type eAccessory ID. Inside the function, use top material map and top slots to override. In the details panel, set category to character customization, so it's easy to find in the node list. Now, for every top button, white top, dark navy top, etc., you reuse the same top function. Just pass the correct enum value. No rewiring. One function, many buttons. Bottom category. Select the node chain that equips a bottom clear enum to iMaterial_from map. Collapse to function. Name it bottom. Add input. Bottom ID, eAccessory ID. Inside, swap to bottom material map and bottom slots to override. Set category to character customization. For every bottom button, gray pants, skirt, shorts, etc., call bottom with the matching enum. Same function, Different enum done. Why this matters. You avoid duplicating long node chains for every single item. If logic changes, for example, you add an extra clear for conflicts, you edit one function and all items in that category benefit. Your UI becomes trivial. On-clicked top white top. On-clicked bottom gray pants. Clean, readable, pro. Tiny checklist so it just works. Inside top, use top material map top slots to override. Inside bottom, use bottom material map bottom slots to override. Keep the clear step targeted clear dress slots before applying a top if those overlap in your mesh. Enum to I-paired IF should be pure so you can plug it straight into material underscore from map without extra exec pins. Name your inputs clearly. Top ID, bottom ID, so the call sites are self-documenting. Real-life vibe. Think of each function as a labeled outfit drawer. You don't rebuild a drawer for every shirt. You keep one top drawer and just pick which shirt goes in. Same for bottoms. One drawer per category, many items, zero mess.
Okay, friends, before we move on, let's do something that future you will thank you for, adding comments to our blueprint. See all these nodes? Right now, we know what each part does because we just built it. But trust me, 3 months from now when you come back after working on another project, this will look like a mystery puzzle. That's why we add comments, little sticky notes for our future selves or anyone else who touches this project. I still remember one day I opened an old blueprint I had made late at night. No comments, just wires everywhere. I honestly felt like I was trying to read someone else's diary in a secret language. I promised myself that day I would never leave a blueprint without some friendly notes. So let's click and drag over each section and add comments. For example, the part where we convert enums to item IDs, we can comment, turn selected clothing category into the correct material slot. The part where we clear and apply materials, we can write, reset slot and applies new dynamic material instance. The part with sliders, maybe, handles color changes, hue, saturation, value. It's just like when you cook and label your spice jars. Future you will thank past you when you can instantly grab the cumin instead of sniffing every jar. Adding these little notes doesn't take long, but it makes your blueprint kind, welcoming, and easy to understand, for you and for anyone else who might join the project. Once you've organized everything, collapsed graphs into clear category functions, added comments, and swapped manual IDs for enums, hit play and test right away. Click every button, try a few items per category, swap quickly back and forth, and drag the color sliders while watching the log. Sometimes a tiny wire, a wrong enum case, or a missing array entry hides until you interact with it. If something feels off, print the enum you're passing. Print the item ID coming from enum to ihorts, and verify the slots array you're feeding into material underscore from map or clear. Test cameras with the back button. Confirm input is re-enabled, and check that only one outfit shows. No stacking. Small, frequent tests now save hours later. Ship the fix while the context is fresh. So guys, let's add 2 more controls to make our color system better: saturation and value sliders. In the WP Character C widget, create 2 float variables named saturation and value. These will store the live values from our sliders. Duplicate one of the existing sliders, like the eye color slider, for each, rename them, and bind their value so they automatically return the variable's current value. This keeps the UI synced if we change the numbers from code. Then, on each slider's onEquiSynced event, take the incoming value and set it to the correct variable, saturation or value. Finally, call your color update function after setting them. This will use HSV to RGB conversion and update the dynamic material instances in real time. This way, players can fine-tune brightness, value, and color richness, saturation, instantly, and our system stays clean, organized, and easy to extend later. For example, when we add hue control.
Slide saturation to go from soft grayish pastels to rich, punchy colors. Slide value to control brightness from deep dim to bright, lively. Use them together and it feels like real dye mixing. Richness on one slider, brightness on the other, so you can dial in exactly the look you want. All right, friends. Before we move on, let's add comments in our BP third-person character so future us can read this in seconds. I'm boxing each area and writing a short why. Init/begin play. Set defaults, cache refs, load maps, and base mat. Clear. Hide slots with base mat. Material time map. Reuse or create dynamic MI. UI and cameras. Enter exit customization. Little tip. Select nodes. Press C to add a comment box. Give it a friendly title and a one-line purpose. Use soft colors per section. Materials teal, UI purple, init gray. These tiny notes are like labels on drawers. When something breaks, you open the right drawer, fix one thing, and move on. Let's label everything now so future us smiles, not squints. I'd love to hear what you think about the whole journey, what clicked for you, what you'd like to see next, or if this helped you in your own projects. Your feedback really shapes what I build and teach next. Thank you so much for following along, learning with me, and bringing your creativity into Unreal Engine. If this series helped you, please like and subscribe. It truly supports me and lets me keep making deep dive tutorials like this. Goodbye, guys. Take care, have a great day, and keep creating amazing things. See you in the next adventure.